right, guys, this is our last practice problem that covers stoichiometry and what we approached in our summer work. This is actually a practice AP exam question. It was taken straight from an AP exam. And we're dealing with a hydrate, magnesium chloride, that we don't know the coefficients of in front of that H2O for this compound. So we don't know the ratio of the moles of water to moles of the anhydrous compound. We're given a data table that summarizes the mass of the empty container, so on and so forth. And then after the first heating, the second heating, and the third heating, the masses of this hydrated sample are recorded. There are two questions to answer involving this free response question. I'm going to give you a few minutes to work them out, and we're going to go over the solutions together along with the scoring guide. For letter A, explain why the student can correctly conclude that the hydrate was heated a sufficient number of times in the experiment. If we go back to this data table, after the first heating, the mass drops because it lost water, 23.982 grams. But then after the second heating, its mass does drop a fairly significant amount by at least the hundredth place here, 23.976 grams. But then if you notice, after the third heating, the mass goes up a little bit. Now, why could that be? Well, as you know, when we work with balances, the last digit will often oscillate between two different numbers. So really, that could just be the random error of just using the balance. So it does seem that after the second heating, the mass didn't change to an appreciable degree. So the official answer would be that no additional mass was lost after the third heating, indicating that all of the water of hydration had been driven off. That would be 1 point out of the total. Then for letter B, we're tasked with finding the total number of moles of water that was driven off in the sample as the first part of letter B. So going back to the data table, if we look here, we can grab one of our final masses, either from the second or the third heating, take that mass away from our initial sample with the container, and that should give us the total number of grams of water that was driven off. Using a simple conversion factor to get it into moles, you should come up with 0.1026 moles of H2O. 4 significant figures, but really the only point that is earned is for calculating the correct number of moles of H2O. Your work really for the AP exam doesn't get taken into consideration unless it's a longer problem. Okay? Then finally, for the second part of letter B, to find the mass of the anhydrous MgCl2, right, the mass of the dry compound, we want to take the mass of the dish away from the mass of the anhydrous compound plus the dish. And that's going to give us the number of grams of what we know is magnesium chloride. Once we have the grams of magnesium chloride, I convert that into moles. And then this last step right here is probably the most important. To find the coefficient that goes in front of the H2O in the final formula, I want to find the ratio of water to the dry compound. It should be either a number that is greater than 1. It should be close to a whole number. It could be a 2, a 3, a 4, all the way up to maybe a 5. It comes out to be about 5.993, and that rounds almost wholly to 6. So therefore, the formula of this compound is MgCl2.6H2O. 1 point would have been earned for calculating the correct number of moles in the compound. So if you at least got up to this step, you would have gained a point for finding the number of moles of anhydrous MgCl2. But then the second point would be the correct formula. So altogether, that question was worth 4 points. So you can actually give yourself a score, see how you would have done. But that really covers everything that we wanted to review for your summer work and before we take your summer work test.